is fired horizontally from the top of a cliff. The projectile hits the ground 4 seconds later at a distance 2 kilometers from the base of the cliff. So from the base of the cliff, the body has reached 2 kilometers away, and the time taken was 4 seconds. What is the height of the cliff? So the diagram for the same will look somewhat like this. Like let us say this is the projectile, and we have kicked a ball, or it's a missile, whatever you can call. So it's a projectile that is fired horizontally, and it is bound to go like this. So this position is basically 2 kilometers away from the foot of the cliff. Okay, and the time taken was 4 seconds, and time taken is 4 seconds. Now in this uh, so we know that the formula for the time period is always root of 2h by g, and from there we can find the range is not actually required in this question. So the time period will be 4 second. uh, 2h by g can be taken as 10, 16, 2h by 10, 8. It will be 80 meters. Yes. So there is the answer. So in this question, as we can see that the data that is given to us is more than what is actually required. So it is done generally to confuse the student. So don't get confused. Range is a completely different thing. And as per as the time of the motion is concerned, the time of flight is concerned, it is based only and only on the one thing: what is the height of the building. It is independent of the velocity u. We know that the formula for time period is root of 2h by g. You can derive it by concentrating on its vertical motion, and we can say that the u is 0 for the vertical motion, and then s is equal to ut plus half gt square. This will be taken as 0. S will be plus h half into gt square, and from here we find the formula that I have used here, root of 2h by g. Okay, so this is how we derive it, and I think the concept should be 100% clear now. All the best. Bye. Okay, so a tennis ball is released from rest at height h above the ground. At each bounce, 50% of its kinetic energy is lost to its surroundings. What is the height reached by ball after its second bounce? Okay, after its second bounce, and that is the most important thing. Okay, so in each bounce, 50% of the energy is lost. So basically, this is the ball, and it goes down, and after that, 50% of the energy is lost. So let us say the potential energy initially it was mgh, and now the kinetic energy is half mv square, and whatsoever 50% is lost. So it means that 50% of the total energy is lost, because as it moves from the position A to position B, the all of the energy which is potential energy is converted into kinetic energy first of all. So 50% of the kinetic energy means 50% of the whatever total energy the body was having, it has been lost. So now it is remaining only 50%. So obviously with this much of the energy it would be going at half of the height. Like why? Because earlier the energy is mgh, but after the bounce, it is mgh by 2. The half of the energy is left with the body. So the mass does not change, the gravity does not change, so height has to change. So it means the body will go up to h by 2. Now it goes for the second bounce, and it again moves up, and 50% of whatever the energy it was having, that has been lost. So the 50% of this, it will be mgh by 4, half of the half. So mgh by 4. It means now it will again attain the height which is h by 4, which is h by 4. So H is the total energy, it is H by 2, and then it is H by 4 further. So your answer will be H by 4, answer will be B. So you are left only with 20%, 25% of the energy. 100% energy, in this it is having 50%, in this 25% of the energy. That is why it is H by 4. All the best. Bye. Okay, so the graph shows the variation of the acceleration A of an object with time t. What is the change in speed as shown by the graph? We need to find the change in speed. Okay, so there is a concept here. The concept is, let us say there are three graphs we have. Now, this is displacement versus time, this is velocity versus time, and if this is acceleration versus time, so there is a connection between all these three things. Let us say there is a body which is moving with an acceleration, whether uniform or whether non-uniform. There will be a graph of acceleration versus time. So with respect to that, we can create the graph of velocity with respect to time. We can create the graph of displacement with respect to time for the same body. And there is a relation between all these three graphs. Now, what is that? Uh, when we go downwards, we find the slope of the curve, and when we go upwards, we find the area under the curve. So the concept is the area of VT curve will give you displacement. This is what I want to say. This is what I want to tell. So, and the area of acceleration time curve, now we are moving upwards and we need to find the area. So area of the acceleration time will give you the velocity at that particular time. Although it is area, the unit is not meter square. Be very careful about that because this is physics, it's not maths. The area is not meter square every time. It depends upon the x-axis and y-axis. So every time we have to calculate the dimension of the area that we are calculating according to the graph, and whichsoever is the physical quantity with that kind of that unit, that is the physical quantity that we are able to find. So this is the area. So according to our question, we need to find the velocity, area, and acceleration and time curve is given. So the area of AT curve will be equal to velocity. So what is the area? Half into base into acceleration, base into height. So this is 6. So your answer will be 36 meter per second. So your answer is C. There's no doubt about that. But there is another thing that I was telling you in the question earlier, in the theory earlier, like if we are going downwards, we find the slope. Now, what is that? Slope means that the slope of ST curve, now we are moving downwards, it will give you velocity, the instantaneous velocity at that time, and the slope of VT curve will give you the acceleration, the instantaneous acceleration. Okay, so always remember, along with these three graphs, if we want to go downwards, like if the displacement time is given and the question is about the velocity, or the velocity time is given, the question is about acceleration, you need to find slope. If it is the other way around, acceleration time graph is given and they are asking velocity, you need to find the area. If they have given velocity time and they're asking question about displacement, you need to find the area of VT curve. I think with this, your concepts will be clear. Okay, then all the best.